fail because it might be too big. So we're basically doing a scope check here. So we need some additional tools. And to write these additional tools, I'm going to use another view. I'm going to call it from NAT. So what this does is that it's parameterized over the upper bound, so over the n here, in the, well, the n, which is going to be the argument to fin, right? So this is the length of the context in this case. And indexed over the input indexed over the number that we want to convert. So this is, again, the same pattern of indexing over the inputs, because we will be able to constrain what the input is, depending on the constructors. So if this succeeds, we're going to get a fin n, which is what we want. And we're going to force that fin n, the erasure of that fin n, to be the input. So this forces the two numbers to be the same, but this new number has got that additional type information. If this fails, we're going to get a number which represents how much out of bounds we are. And we can assure that this is the case by forcing the input to be n, so the upper bound, plus m. So this is, right, so this expresses the fact that the input is bigger than the upper bound. Once we have this view, we can write a function. So we've got the upper bound, and we've got the, our number, and we want back a from nat and n. And this is probably the neatest example of just the function writing itself.